The theory of relativity. Its name alone is frightening, something incomprehensible, which conjures such incredible things that scare you.
I grant you that there are things that seem difficult, but not so difficult.
Do you really think you can drown me into this adventure?
Sure. Don't be afraid. You know, everything began with the curiosity and the dreams of a young boy. That was the time when big efforts were being made to take off from Earth in rudimentary flying machines, and many were dreaming of flying. And it was the time of the first successes in sending messages by means of waves emitted from simple electrical circuits. But the world of science was shocked by a true paradox. Certain experiments had undeniably shown that despite the rapid motion of the Earth in its orbit around the Sun, the light of a star was always measured at the same speed, either when the Earth was moving against it or going in the opposite direction. The boy I mentioned, he dreamed he was flying astride a wave of light, and he wondered what his view of the world would be then. And even when he grew up and was studying at the Polytechnic, he still remembered that dream.
Un bel giorno,
one day, we don't know how or when, an idea occurred to him, and it seemed to be the simplest way to face the paradox of light. The speed of light is always the same, however you move, because all the rules that govern the phenomena must appear the same from any frame of reference. The boy was Albert Einstein, and at the age of 25 he published his special relativity theory while working as a simple employee in a patent office. This theory takes into account only the effects of uniform motion, but succeeds in giving a sense to the paradox of the speed of light, and foresee many phenomena in nuclear physics and in the cosmos.
L'effetto sul mondo scientifico.
The scientific world was puzzled. Although this theory gave no new results when the velocity was low, it had incredible consequences when the objects approached the speed of light, and it calls into question the very concept of space and time, which no one had ever doubted before.
A grandi velocità.
At high speeds, this theory predicts that the flow of time slows down and that the objects shrinks along the direction of their motion. But these paradoxical aspects are not really much different from those that occur commonly in our three-dimensional space, which we take for granted, so no one wonders about them. The image we have of an object changes if we change our observation point. It changes in a very precise way, according to the rules of geometry. And we perceive this in a fully intuitive form, because billions of years of evolution have introduced some rules of Euclidean geometry in the hardware of animals' brain. Essentially, the Pythagoras theorem and little else. But three-dimensional space is not sufficient when we deal with high velocities. Time must also be considered, and the theory of relativity is essentially a new geometry which adds an extra dimension to normal space, albeit different from the other three: time. And in this space-time, the effect of motion of an object is represented in a similar way to a rotation in ordinary three-dimensional space. So we see that the meter shrinks with motion and the ticking of a clock takes longer, in the same way as we see the sides of a cube changing when it rotates.
Quando lo ruotiamo.
So the magical speed of light always remains the same. And nobody will ever ride on its way, but its dreams that open new horizons.
I still don't understand how time and space behave like this.
Hai ragione.
You are right, you cannot understand. Nobody can understand intuitively what happens at nearly the speed of light, because we evolved in a completely different environment. A cat cannot understand what flying means, but a seagull can. But if you build the right tools, like wings to fly, then Einstein's relativity will magically appear similar to the geometry of Pythagoras and Euclid.
It's as if everything we see would also look incomprehensible if we were not accustomed to it.
Beh, più o meno.
That's the way it is, more or less. But there was another recurring thought in the young Einstein. What is the origin of gravity? If all bodies fall with the same acceleration, might it be that gravitation too is just geometry? Took further than years to substantiate this idea in mathematical terms. And this was the general relativity theory, which contains the preceding special relativity, and explains gravitation as being a deformation of space-time due to the mass of the objects, essentially just as the surface of a mattress deforms if we sit on it. In the 70s, it was possible to verify that an atomic clock on board a jet goes differently from identical clocks on the ground, and that a clock on the seashore proceeds more slowly than one placed on the top of a mountain, where gravity is a little less. The effects are, however, only a teeny fraction of a second.
Ma al giorno d'oggi.
But today, these properties of space-time are essential also for our little satellite navigation system that could never guide us properly without taking account of the different passage of time in the reference satellites. General relativity is now the way to interpret all cosmic phenomena, such as the evolution of stars and the origin of black holes, monsters that open a sort of well in space, where everything is sucked in and nothing can escape, not even light.
In the present world, It seems that nothing can be done without computers or powerful machines and within a big organization. So I wonder how it is possible that a single man succeeded in making such a step and conceiving a theory like this. And before he became famous, he was even forced to do another job to survive.
Fare un altro lavoro per sopravvivere.
Modern technology gives us great opportunities, but it will be of little value without the continual renewal of those who are enchanted by the mysteries of reality and face them with the enthusiasm and the curiosity of a child.
I understand. Just like the boy who dreamt he was flying astride a ray of light.
Sognava di cavalcare la luce.